Hi friends! So we're going to look at a couple problems on the back of the notes. Okay. I'm going to show you some things about using Desmos to help us do some of these problems. And I'm not sure I'll do it on this video, but if I don't, we will look in class about how to do this on the handheld calculators as well. All right, so problem number 3, let's see if it'll let me jump around. This might be the problem. This might be a little mouse issue for myself. Where is my mouse? Hello, there you are. Come over here. Okay. So if I pop that. Okay. So there's number 3. And number 3 has two curves, x squared plus 2x plus 1 and 2x plus 5, but we don't have a graph. Now, we can graph these on the graphing calculator to get us an idea of what the picture looks like. We can graph them on Desmos to get an idea what the picture looks like. We can see that we're not given any left and right boundaries, so that's a clue that we should be looking for intersections as boundaries. So I'm going to use Desmos since we've got access to it, and it actually, I think, in some ways is easier. Let's see if I can go back to my Desmos. Yes, I can. All right. Okay, so here we go. We're going to type in our function. So y equals x squared plus 2x plus 1. Okay, yay. And go down here into another box. And y equals 2x plus 5. And Desmos understands that we want to treat these functions separately, so it makes them two different colors for us. And if we would like to change the colors, we can just, I think, click and hold. Yep. So maybe you want a purple one instead of a blue one, you know, whatever floats your boat. Desmos is super nice in that it shows us the intersections really easily, and all we have to do is click on them. And if we click, it'll actually leave them highlighted. So it looks like the area, if we want to draw ourselves in there, the area we're looking at is going to go from a left boundary of -2, because our left and right boundaries are x's, and a right boundary of 2. Now, my question would be, well, which guy's on the top? Desmos luckily color codes things for us, so we can see that it looks like the line is actually the top function and the parabola is the bottom. The line is what's above our head, the purple guy's above our head, and the red one is under our feet. So if we were putting this on our notes, I was going to show you something else about looking at. Okay, and what are we doing? Sorry guys, just doing a little quick stuff here. All right, so it looks like, let's see, 1, 2, 3, 4, 5 was our line. Oops. But it's a positive slope line, not a, oh, it's positive slope line, yeah, so it's that way. And it's a slope of 2, so we can do kind of a rise over run, but down. We can also show you on Desmos. Something you can do on Desmos is, well, let me go back. Yep, okay. If you highlight a particular function and click the gear and click the table. Oh, it's not going to let me because I've got all kinds of graphs. Ugh, I got all kinds of other stuff written here. Let me erase my bottom and my top and see if it'll let me do it. Gear, table. It gives you some points. So on my curve, it's highlighted, on the parabola curve, it's highlighted some of the points for me. That makes it a little easier maybe to transfer it over if I'm graphing it on notes or on a homework paper. So negative 2, 1, negative 1, 0. Negative 1, negative 1, 0, and then 0, 1, and 1, 2, 3, 4, and then, so kind of went like that. Oh, and I apologize for not color coding. Here, maybe I'll go over this guy. So here's my line. Yuck. And here's my parabola. If I was smart, what I should have done is graph them here and cut and paste them. It's actually not a bad idea if you wanted to do that for any of your assignments. The little wrench. Nope, not the little wrench. What do we use? Oh, the little, get the graph. Get the graph. And we can just go here. And that's actually something you can right click and copy that image and paste it in. It's ginormous. It comes in super ginormous. Oh, look at that. That's crazy. I know you guys are like, why will you please edit this? I'm going to delete that, but we could play around with that. We could make our graphs look really pretty. Okay. Get to the good part, Mrs. Willenbrock. We set up the integral. Go to the note part. All right, so we're going to set up the integral. We figured out from our Desmos that they intersected at 2 and negative 2 and 2. So negative 2 to 2, 2x plus 5 minus x squared plus 2x plus 1, bam, bam, dx. Now, that's a lot of antiderivative, integration, simplifying, big F, or little f, big F, plug in 2, plug in negative 2. You're probably thinking, or somebody may have already shown you, there's got to be something that will do this for me. There is. Graphing calculators of all types. Can I get out of here? All done. I don't want to leave, I just want to not do that. Okay, there we go. Let me get rid of this little table. Watch what I'm going to do. First thing I'm going to do, so I know what's going on here, I'm going to give these functions better names. I'm going to use little subscripts. Since my purple guy's on the top, I'm going to put a y sub 1. All I did was type a little 1 right behind the y. And y sub 2. So now the Desmos is very clear, not just color-wise, but algebra-wise, which one is which. Because watch what I can do. If I go into the keyboard, and I go into the functions, and I scroll down, all the way to the bottom-ish, not all the way to the bottom, but close to the bottom, there's calculus functions. There's our friend, the integral. Oops, I always do that. I end up getting something else. Back him up. Okay, there's our friend, the integral. Just waiting for us to type stuff. So the bottom number is negative 2. The top number was 2. Okay, this is what we wrote on our paper. We had to know what to write. Negative 2 to 2. Now watch this awesomeness. Because I'm so lazy, I want this guy to be first. I'm not going to have to type all the stuff. I'm just going to type y1. Oops. No, I'm not. I'm going to lie. I'm going to put a set of parentheses first. Oops. No, I'm not. Why is it in? Oh, no, 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 no. Come back, come back, come back. Oh, poopy. All right, hang on, everybody. I don't want to have to do this video again. You guys are probably laughing your heinies off at me right now. You're like, seriously, that's Brock, you're super extra. All right, let me put this over here. All right, let me get rid of all that nonsense. Okay, it is just waiting for me to type stuff. It's kind of mad because I'm not typing anything. So I'm going to put y sub 1. Actually, I do need parentheses. Parentheses. Actually, I need the parentheses before the y. Okay, parentheses. y1, because that's the guy on the top, minus y2, that's the guy on the bottom. Close my parentheses. But it doesn't do anything. It's a calculus equation. It needs dx because the y's are in terms of x. And it does the calculation for you. Yeah. It did it all along. We actually never needed... Fundamental theorem is great, and it's how you do it by hand. Basically, the program can replicate the fundamental theorem process, but does it with geometry and gives us the same number. If we want that as a fraction, we could do that. So now, if you're sitting there going like, wait a minute. Maybe you go back to problem 2 and you're like, well, wait. What if I don't graph it on here? Well, that's okay. You don't have to graph it as long as you know the equations and you're willing to type them in. Me and my touchpad are just not. And then go across. Okay. I don't know if there's a shortcut to get to the integral function other than going here. If anybody figures that out, they can tell us. Oops, I don't want it up there. Hang on a second, guys. If I were smart, I would pause this and you guys wouldn't have to watch me be so not organized. You're like, fast forward, Mrs. Willenbrock. It's just like class. It's real. This is why I'm not a professional video maker. There we go. All right. Can't stop me now. Number 2, remember that one? -3 to 2. The curvy function was on the top. 6 minus x squared. Close that up. Actually, I think we're going to need a couple sets of parentheses. So we need a big set. We need a set for the first function, and then we need a minus, and then a set for the second function, which in this case was just x. Close up the whole thing. This is why it's a little easier to have them with those special y names. dx. What did I tell you that answer was? Boom. So, on the remaining problems, and on the problems on your assignment, I'm going to want you to graph. I'm going to want you to sketch a picture of the area. And I'm going to want you to set up an integral. You need to show me the integral that you use to calculate the area. And then once you get that, you can use your technology to solve it. Try problems 4, 5, and 6. I will have the answers all written out for you so you can check. And then you'll see you have a 5-problem assignment to do from problems in the textbook. Thanks, everybody. I know that this video is probably worth a good laugh for me being me. Hope you guys have a great day, and we'll talk about this more next week. Good luck on your AP exams.